Hello and assalamu alaikum to all, and welcome to the third episode of our online lectures, and we are on the chapter vectors. So let's start. So the topics for today are resolution of a vector. We will see the definition of the resolution of a vector, what is the method of resolving a vector, and then what are the components of a vector, and mainly the rectangular components of a vector. Okay, so here we have the definition of the process of resolution of a vector. So what is the resolution of vector? Let me explain a bit. Like in the previous topics we discussed the addition of vectors. So when we added two or more vectors, we got a single vector which was called resultant vector. Now this is the reverse of addition. If we split a single vector, we will get two or more smaller components of that vector, and this process is called resolution of a vector. Okay, we can resolve a vector into infinite components, but at this level we will resolve a vector into mainly two components, which we will discuss later. So what is the resolution of a vector? The process of splitting up a single vector into two or more components is called resolution of a vector. The process of splitting up a single vector into two or more components, smaller components, is called resolution of a vector. Okay students, now we will see an example of how to resolve a vector. Let's say we have this vector whose magnitude is this f, and the direction is given by this angle theta, so it's going in this direction, and we have to split this vector. Okay, so into how many components we can split this vector? We can split this vector into infinite components, but right here at this level we are able to resolve this vector into two components, and these components are also called rectangular components. Why they are called rectangular components, we will see later on. Rectangular components. And what are these components? The first component is along the x-axis over here, and the second component will be along the y-axis like this. Okay, so let me draw these vectors. So I will make sure this line doesn't cross this level. This will be the y component, or we also call it vertical component. And this will be the second component of this vector, and this is the horizontal component. We call it fx. The way we named the previous vectors f1 and f2, we name it fx, the horizontal component, and this is fy, the vertical components. What is the formula for the magnitude of these components? We will see in the next section. So this is the way we resolve this vector into its horizontal component and vertical component. Let's take more examples. Students, so we have some examples over here of different vectors in different directions and magnitude, and we have resolved them into their vertical components. Like in the first one, we can see this vector f is more leaning like this towards the x-axis, so its x component is more than its y component. Okay, so we split this vector f into its x component and y component. Why the magnitude of fx is more? Because the vector was leaning more towards the x-axis. Okay, so this vector f is split into these two components, and if we add these vector by head to tail method, then we again gonna have the same vector as the resultant vector. Not by simple mathematical addition, we have to add these vector by head to tail rule again to get this vector, or by applying the formula. Okay, over here you can see the y component is more in length than the x component, because this vector f was more leaning towards the y axis. Okay, so that's why its y component is more than its x component. So we split this vector f into its component fx and fy, and if you again add them by the head to tail rule or the rectangular component method, we will get again this vector f. If we add these vectors again by head to tail rule, then we're gonna get this vector again. But here we are having a look at resolution of vectors. So we will say that we resolve this vector into these components. We are not adding these right now. Okay, and the third case, you can see the vector is along the y-axis. So here its y component is equals to the complete vector because it doesn't have any x component. This is the original vector we have. So this will be the y component as well, and there is no x component over here in this case. And in this case, our vector is only in the x direction along the x-axis. So all the vector is equals to its x component, and there is no y component over here. Clear? So these are the 4 different cases of resolution of a vector, and we saw that we have these x and y component in different values. Students, so now we have to study these components in detail. So we are starting the topic, the rectangular components of a vector. We resolved our vector into 2 components. The first component is x component or horizontal component, and the second one is y component, or we call it vertical component, and their names are fx and fy. These are also vectors. Okay, so we were given with a vector f with a certain direction represented by this angle theta. This is a symbol theta for the direction, for the angle. We use this variable for the angles. Okay, so we will be given by some vector along with its direction. This vector means its magnitude. Okay, and the direction in degrees. So how can we find the x component? We will draw it obviously, but we have to find its value as well. So this will be the formula for the x component. The fx will be equal to f cos theta. This cos is basically cosine, it's a trigonometric ratio. We can solve this by a calculator. And this fy, the vertical component, will be equal to f sine theta. So we put the magnitude of this vector f over here, like if it is 5 Newton and at 30 degrees. So we will put the value 5 over here and sine 30 over here. First we find the value of this sine 30 with calculator, then we multiply it with 5. So we will get the magnitude of this y component, this y component, this x component and y component. So these are the rectangular components of a vector, fx and fy. This is the horizontal one and this is the vertical one. We will further see how to find these components with an example. Okay students, so we will see how we can find the components of a vector when we are given the magnitude and direction of a vector. So the question is, find the rectangular components of a vector whose magnitude is 5 Newton and the direction is 30 degrees. So we are given with a vector and we have to resolve it into its components, and we have to find the values of its components. So we are given with a vector whose magnitude is 5 Newton and the direction is 30 degrees, which is represented by this variable theta. So first we find the x component, which we call horizontal component as well. The formula for this is this fx is equals to f cos theta. So what we will do, we will put the value of this f is 5 Newtons, we only write 5 over here. and cos 30 because the angle is 30 degrees. So first we find the value of cos 30 degree with the calculator, and that is 0.866, and then we multiply this with 5 and we get the x component, and this x component is 4.33. Since it's a vector and a vector of force, so the unit will be same as Newton. Okay, so this is the x component of this vector. Now we will find the y component or vertical component. So students, for y component, the formula is Fy is equals to f sine theta. We first put the value of this f, which is given as 5, and the theta is 30 degrees. With the calculator we find that sine 30 is 0.5, and then we will multiply this 0.5 with 5, and the answer is 2.5 newtons. So we can see that the y component is less than the x component because the vector f is more leaning towards the x-axis because the angle is 30 degree. If the angle was 45 degree, both the x and y components would be same. And we can also see that if we add this y component and x component, we will not get the same value of 5 because the x component was 4 point something and the y component is 2.5. If we add them, we will get the answer around 7. Okay, so we cannot add these components and get the resultant answer by simple mathematical rules. We have to add them by head to tail method. Clear everyone? So these were the topics for today. We will see different problems related to the chapter vectors. All the problems are next topic. Till then, take care.